Okay, class, we're looking at integration of inverse trig functions. Now, you've all seen the formula sheet already. To fix the screen up there. So integration of inverse trig functions. Remember, the only rules that you're going to get are the integrals sheet here that I've just got there, okay? So you're going to get the integrals sheet. So the first one, if you integrate the square root, 1 over the square root of a squared minus x squared, it's inverse sine of x on a plus c, this one here. Now if we look at the first one, if a is 1, obviously we've got this first rule here where I'm clicking there. So if a is 1, 1 over the square root, integral of 1 over the square root of 1 minus x squared is the inverse sine of x. That is if a is 1. And if a is some number other than 1, like 2, for example, that second rule is exactly as you see it on the formula sheet for the integral. Now, we know that we don't have the integral for the inverse cos, but the inverse cos one, remember, was the negative of the sine one. So if we look at the third rule here in your textbook now, this rule here, integral of the negative 1 over the square root of 1 minus x squared, that is the same as negative sine, which ends up being the cos, inverse cos. Notice here on the formula sheet, there is no integral that gives you inverse cos. Remember, it's the negative 1 over. That's what I'm saying.
Alternatively, you could just pull out the negative, couldn't you? And you just change.
Yes, you could pull out the negative in front of the bracket and make it a sine one if you wanted. Yeah. Okay. So same with the a. Negative 1 over the square root of a squared minus x squared would be inverse cos. Okay?
So we still write this down?
You can just, yeah. And then, look, you're just going to be able to use what's on your formula sheet, but you can write it down. Also, integral of 1 over a squared plus x squared is the inverse tan 1. And if a is 1, integral of 1 over 1 plus x squared is inverse tan of x. All right, so you've seen these already. We've been differentiating. So we've been using these integrals for differentiation. We're now going to use them for integration. All right, the integral of 1 over the square root of 4 minus x squared, we know that that's in the form of what? That's exactly as the formula sheet is, where a is 2. So it's 2 squared minus x squared dx. So that's looking exactly like the formula sheet for the inverse sine of x on a. So that one is inverse sine of x on 2 plus c. That one's fine. Let's look at the next one. Girls, just be really, really careful with this. Girls, having a look at this one, I'm going to write down what the rule here is on your formula sheet. I'm going to put it over here. And the rule on the formula sheet states that the integral of dx over a squared plus x squared is 1 on a inverse tan of x on a plus c. Okay, girls, look at both of those and compare them. What do you think we should do? Yeah, we can take the 5 out. But girls, what would you, depends how you want, depends if you want to have this looking as 1 on a or putting, what do you want to do? What do you think it's going to be? I want you to think and have a go, and then we're going to look at it in a sec. But according to this rule, you either want, what would you want on top for this rule to work? Remember, you got the 1 on a here. You either want a at the top, or you'll do the integral here with a 1 at the top as it stands, and you put 1 on a in your solution. Do you see? I think you should do that. I think you should keep the 1 on the top, girls, as it is there. So with the integral here as it stands, there is a 1 dx here. Are we okay with that? So therefore, the integral is 5 times, what do you put here now? What does a equal? I'm going to write this as 2 squared, by the way, girls. Can you see that? So that is 5 times the integral of 1 over 2 squared plus x squared. So it's 5 times, I want it to look exactly as the formula is. 5 out the side the front, 1 over 2 squared plus x squared. So it's going to be 5 times what? 1 over 2, yeah. Inverse tan, sorry, 5 times, yeah, inverse tan of x on 2 plus c, which becomes just 5 on 2. 5 on 2 inverse tan of x on 2 plus c. Can you read that properly or not really? That's there. What about the next one? I want it looking like the formula. It is like the formula, but something squared is 3. 1 over x squared plus root 3 squared dx. Do you see that? This is question I. It's question I. So we're integrating 1 over x squared plus 3. So it is looking like this. 1 over x squared plus the 3 is the a squared, therefore a is square root of 3. So it's root 3 squared, so that will just be 1 over what? 1 over a, whatever that is. What's a? 1 over root 3 inverse tan of x over root 3 plus c. Next, ready? Are we okay? All right, this one is a bit different. I'm going to write the rule that you would see on the formula sheet over here. The rule on the formula sheet is the integral of dx over the square root of a squared minus x squared is inverse sine of x on a plus c. That's the rule on the standard integrals sheet. All right, we've got a bit of a problem. What's our problem? How are we going to pull out the 4?
You pull out the 4 underneath the square root, then you get 2 and
We're going to make a common denominator. We're going to make a common denominator, and then we'll go with other methods in a minute. So, isn't that 4 over 4 minus, so we're going to pull out the 4 bracket 1 over 4 minus x squared. Are we good with that? So that is identical to that. We need just an x squared here. So we've got dx over the square root of. So we've got to pull the 4 out because we only want an x squared term. It's 4 bracket a quarter minus x squared, close bracket. All right? Which is, girls, what's the square root of 4? 2. So I'm going to pull out, the 2 can go, 2 is on the numerator or the denominator of the fraction. Can I pull it out the front then? Can I pull it out there? Dx over 1 quarter minus x squared. Are we okay with this, girls? The square root of 4 is 2, so there'll be a 2 out here, but let's put it out the front because it doesn't get... Are we okay with this? All right. So, girls, this needs to look like a squared minus... I think it's a plus. I think I've written it out wrong. Oh, no, it's right. I've got a square root sign too. Okay. So it is minus. Which one is it?
the sign.
Half times the integral of dx over the square root of a half squared minus x squared. That's how now we recognise it. Girls, are we okay with this 4? Square root of 4 is 2. So we'd have a 2 out the front of the square root. We may as well bring it in the front to the front of the integral. So what do we got now? Now we can do it. So that's a half times the inverse sine of x divided by a half plus c, which is what? A half inverse sine of 2x plus c. Let's do another one of those. Let's do question 2e. Integral dx over the square root of 4 minus 25x squared. It is another sine one. Actually, let's make it a cos one. Negative. Okay, it's not, oh no, keep it positive. Keep it like the textbook. It's a textbook one. 2e. on your formula sheet, we want a squared minus x squared, so we don't want this 25 in front of the x squared. How do we write it? Well, yeah, we go square root of 25. 25 is still under the square root sign. So we'll get minus x squared. But girls, what's going to happen here? How am I going to go? I want a 4 up here. How am I going to undo this? I'm not pulling out the 5 yet. Do you see what I've just done? Girls, I have to pull the 25 out because it's got to be square root of a squared minus x squared. So the 25 comes out, big bracket. Can you see what I've done there? Then it's 4 over 25 because 25 times 4 over 25 is 4. And we've got 25 times negative x squared. So I've got 25 bracket 4 on 25 minus x squared. Now, square root of 25 is what? 5 square root. The 5 comes out of the square root of 25 is 5. That comes out of the square root sign. We've still got 4 on 25. That's got to be written as a squared number. So what's that? 2 on 5 squared minus x squared. Now I can integrate. Yeah, let's pull out the, so it's a 5th times, so now we've pulled out the 5 to the front. Pretend the 5's out the front now. And what do we do? Do I have to go? A 5th times the integral, which will be what? Inverse sine of, do you know what we're doing, girls? X divided by 2/5 plus c, which is 1/5 inverse sine of 5x on 2 plus c. Girls, are we okay with this? All right. We'll do one more. Integrate 3 over 9 plus 16x squared dx. We're going to pull the 3 out because we want 1 on the numerator. So it's 1 over. We need it to be looking like integral of 1 over a squared plus x squared dx. So we're going to pull out the 16 because we don't want 16x squared. We just want 1x squared. So we pull out the 16. So 16 times bracket 9 over 16 plus x squared, close bracket. The 3 is a constant, so is this 16 on the denominator. So we have 3 over 16 outside. 1 over, this needs to look like a squared plus x squared. So what is it? 3 on 4 squared plus x squared. So therefore, we're ready to go now. It's 3 over 16 times. Be careful, look at the formula. It's 1 over a, remember? 1 over 3/4 inverse tan of x divided by 3/4 plus c. Just be careful. So it's 3 over 16 times what? Times 4 on 3 inverse tan of 4x on 3 plus c, and simplifying again, the 3's cancel. What have you got? 1/4 inverse tan 4x on 3 plus c. All right. And J, that's the cos. And we want it looking like, how do we want it to look? What can I take out straight away? The -2. What else can I take out straight away? And the 5, I still will have to take out something later. Actually, I'm not going to take the negative out. I'm going to leave -1 so I can make it cos. Otherwise, I've got to take the negative out and make it sine. So let's make it cos. Square root of, I don't want it looking like this. Let's fix up. So girls, I'm not taking out the negative. It's 2/5 -1 so that my answer's cos. Let's fix up this x squared thing first. What do I put at the front here? 9. I don't want 9x squared. What have I got now? 25 on 9 minus x squared. Close bracket.
So we did pull out the negative to lose a lot.
No, as long as you now put that it's negative sign.
Okay.
Yeah. So 2/5 times. What's going to happen to this square root of 9? So can I put the 3rd out the front? See what I'm doing? -1 over. So this square root of 9 is the 3. I'm bringing it out. What do we got? How am I going to write 25 on 9? It needs to look like -1 over the square root of a squared minus x squared. Waiting.
5 on 3 squared.
5 on 3 squared minus x squared. Are we good, girls? The square root of 9 is 3. I'm pulling it out. So what have I got? 15 times inverse sine of x over
Yeah, it's close.
inverse cos of x over x over 5 on 3. I could have just written it properly. So it's 2 over 15 inverse cos of,
3x on 5.
I keep doing it wrong, 3x on 5 plus c.
Or you could have minus.
So the other answer to this could have been, if you decided to put the negative out the front, so if you decided to make it negative 2/5 times the integral of negative 1 over, sorry, with that 3 there too, over the square root of 5 over 3 squared minus x squared. No negative 1 there. So if we decide to put the negative 1 out the front, or say out here, you could have also got negative 2 on 15 inverse sine of 3x on 5 plus c. Now, evaluate the following. The integral from 1 over 7 root 2 to 0, 3 over the square root of 1 minus 49 x squared dx. You want that to look like 1 over the square root of a squared minus x squared. Do you want to have a go yourselves?
Yeah.
We pull out the 3, 1 over 7 root 2, 0. 1 over, we need a squared minus x squared, so what's it going to be? You can, do you know what you're pulling out? I need an x squared. I've got to pull 49 out. 49, 1 over 49 minus x squared dx. I shouldn't probably put that 1 on 49 in brackets as well. So what do you end up with? 3 on 7. Because the 7 square root of 49 is 7, it comes out. 1 over 7 root 2, 0. 1 over the square root of what? How are you going to make that look? 1 on 49 is what? 1 on 7 squared minus x squared, which is, now, 3 on 7 inverse sine of, no, in brackets, inverse sine of x divided by 1/7, no plus c, 1 on 7 root 2, 0. Probably to save some time, you may as well write that as 7x to start off with. 1 on 7 root 2 and 0. Okay, are we good? Is that what you got?
Yeah.
3 on 7, inverse sine, what's 7 over 7 root 2?
1 on root 2.
It's 1 on root 2. Minus inverse sine of 0. So sine of what gives you 1 on root 2? So, yeah, that's how you do it. Sine of, yeah. So sine of what gives you 1 on root 2? Sine 45, which is pi on 4. Sine of what gives you 0? 0. So therefore it's 3 pi on 28. Guys, find the area bounded by the curve. Question 4. Y equals 1 over 1 plus x squared, the x-axis, and x equals 0 and 2. Now, whether, see, you know, with area bounded by curve, you've got to know whether part of it is above or below. But let's just look at all our values of x. When x is 0, do you get a positive value? You get 1.
So it's always
When x is 1, you get 2, a half. And when x is 2, you get something positive as well, don't you? When x is 2, you get 1 on 5 is a fifth. Look, the curve's going to look like this. The main thing that you need to know, because it's area bounded by curve, I'm not asking you for the integral, I'm asking you for the area bounded by the curve. The main thing you need to know is this curve all above the x-axis or all below the x-axis, or is part of it above and part of it below.
So
But if you didn't know, well, you're supposed to go, if you just do the integral and you don't know, you'll get the integral, and the integral will subtract the bits underneath the x-axis from the bits above, and you won't end up with the area.
Just put it in.
absolute value signs, but you know not all of it. Only the bits that are below go in the absolute value signs.
Why though? Because positive just comes out positive anyway.
No, because when you're subtracting something like this, the values are pretty easy. When x is 0, y is 1. When x is 1, y is a half. When x is 2, y is a fifth. It's all above the x-axis. It's all good. The area is all above the x-axis. So therefore, it's just the integral from 2 to 0 of 1 over 1 plus x squared dx. Girls, this is the most basic type. That's not a hard integral. Which one's that, the sine or tan? Yeah, so that's just tan to the minus 1 of x, because a is 1, between the values of 2 and 1. So it's tan to the minus 1 of 2 minus tan to the minus 1 of 0. Now, girls, inverse tan curves, inverse sine curves, inverse cos curves, they're all done in radians. Like, I'm going to draw inverse tan. Do you know where your asymptotes are? It looks like that. Do you know what these labels here are? Pi and 2. Yeah, it's not, it doesn't say 90 degrees, negative 90 degrees. It's pi and 2, negative pi and 2, inverse tan, inverse sine, inverse cos curves are all done in radians. So you need to convert to radians mode. Girls, what's inverse tan of what is 0? That's 0. Inverse tan of 2. Guys?
You get 1.1, 0.7, 1.
Etc. So therefore it's 1.1 units squared. Do this as a log? We can't. The only time you would do it as a log if it was integral of x over 1 plus x squared. Now if I was doing that as a log, see, integrating a fraction is when you use logs, but what would you really want on this numerator? You'd want 2x over that, and what do I balance that 2 that I just happened to throw in? With a half out the front, and then put your values in. That's when you do a half ln 1 plus x squared. So good question, but please, if there is a constant on the numerator, please have your integrals sheet. Hopefully with all your practice you'll be familiar with it, but unless the numerator is the f dashed, is the derivative of the denominator, or close to it in terms of x, it's got to be the right power of x. If it's not going to be the right power of x, don't go there. All right? Question 5. If the curve y equals 1 over the square root of 1 minus x squared is rotated, so find, not if, can we put find the area? Oh, it doesn't matter. If that curve is rotated about the y-axis between the lines, I know this is going to seem weird, x equals 0 and x equals half. So I should put find the area. Find the area if. Find the area if the curve of the volume. Find the volume if the area between, sorry girls. So find the volume if the area between the curve y equals the square root of, no, y equals 1 over the square root of 1 minus x squared is rotated about the y-axis. But they're giving us x values here, not y values. Okay, so we've got to get the y values. So, all right, I'll draw a little sketch. Yes, because if you're integrating dy, you substitute in y values, not x values. So find the volume if the area between that curve, and x equals 0, x equals a half, I should put it there, is rotated about the y-axis. Yeah. So it's a volume question, rotation about the y-axis. Sorry, it's very messy. Let's just write the formula down. Volume is integral pi, integral b on a, it's x squared dy. So girls, I don't have x squared. These b and a values have to be y value. Not x is 0, x is a half, but the corresponding y values. Okay, so let's work first with rearranging this equation. How?
Sub in the values first.
Oh, we can, but I just want to make x squared. All right, let's substitute the values in. When x is 0, we need to know what y is. Y is 1 over the square root of 1 minus 0, which is 1. And when x is a half, y is 1 over the square root of 1 minus a half squared. What's that? It's 1 minus a quarter, which is 1 over the square root of 3/4, which is 1 over, isn't it, what is it, girls? That's right. It's 1 over the square root of 3 divided by 2, because it's 1 divided by the square root of 1 minus a quarter, which is 3/4. Square root of 3/4 is square root of 3 over square root of 4, which is 2. So it's what? 2 over root 3. So that's your B and A. And it doesn't matter which one's bigger and which one's smaller. The 0... Wait. Maybe. No, you put the bigger y value in. Yeah, you'll put the bigger y value in. Sorry, that doesn't apply because maybe the curve goes like that. And the smaller x, or like this. The smaller x could be the bigger y, and the bigger x could be the smaller y. You put it bigger number on top. This is not integration by substitution.
So that only applies.
If the curve goes down, they will be swapped. If the curve goes downwards. The only time as x will be small, as x, small y, big x, big y, is if the curve has a positive gradient. All right, wait a sec. Can we start with this? Let's just finish this off. How do I get rid of this square root and make x squared the subject? Square both sides. Oops, that's a minus. Now what do I do? Can we swap that and that? 1 minus x squared equals 1 over y squared. And therefore, can we swap sides as well? So 1 minus 1 on y squared equals x squared. That's looking good. So, good. So now you are integrating. This is not looking good. Oh, actually, I don't even think it's a... All right, one sec. Yeah. I don't think we need to use... I don't even think it's an inverse function anymore. So volume is pi b on a 2 root 3. What's 2 over root 3? Is it bigger or smaller than 1?
Bigger.
It's 2 divided by 1.7.
It's bigger. Yeah.
All right. And 1. X squared is 1 minus 1 on y squared dy. Girls, this can be done without inverse functions. So pi, integrate 1, you get y. 1 on y squared happens to be y to the negative 2. Now integrate it. Increase the power by 1. Don't put negative 3, please. Minus y to the negative 1 over negative 1. 2 divided by root 3 and 1. So just be careful here. So it's pi, what does this become? Y plus 1 on y, 2 over root 3 and 1. So it's going to be pi 2 over root 3 plus, what's 1 divided by 2 over root 3? Isn't it just root 3 on 2? Yeah. Minus, bracket, minus what? 1 plus 1. So it's whatever that is. And then you have to go common denominator more than likely. Yeah, common denominator and rationalise it. So we've got pi. Common denominator is 2 root 3, isn't it? Why don't we multiply everything by 2 root 3? No, you can't. Common denominator. Common denominator. What's this one missing? A 2. So it's 4 over 2 root 3 plus root 3 squared over 2 root 3 minus 2 times 2 root 3. I'm going common denominator of 2 root 3. Let me do it again. All right. I'm going pi. I want a denominator of 2 root 3. So the first one becomes 4. Yeah? Times 2 times 2. The second one gets multiplied by root 3, which is 2, which is 3. And the last one gets multiplied by 2 root 3. So it's 2 times 2 root 3. Can you see that? So what do we got? Pi. What do you got? 7 minus 4 root 3. We're still not done. You need to rationalise it. Times numerator and denominator just by root 3. And we get pi, what? 7 root 3 minus 12 over 6. Units cubed. They take the 6 out, but that's fine. They put pi on 6 at the front. So they've got pi on 6, same thing. 7 root 3 minus 12 units cubed. All right, for homework, can you just do the exercise? But question 1 and that, don't do every single. Just do the ones that look interesting. Can you just please do this whole exercise? Just don't do the ones that we've done. I know it's a lot, but you really need to practice it, all right? So just do the whole exercise. And also, I've sent you Cambridge, exercise 1E. Have a go at that on the weekend as well.